Okay, so like the previous exercise session, we will go to our own Jupyter Hub of Alto, and other students, like the outside student, have already got the email from Alex, right? Yeah, just a moment while the server is running up. Mhm. Sorry, just a moment. Okay, so right now we will go to NB Gather and then check the assignment list, like here, and you will see the new assignment list here, the assignment 2. And after that, like if you guys fetch this one, then you will see the assignment here. Then after that, like you can see the assignment, and also you can go from this folder, like FL 2025, after that, the assignment 2. Okay, so this assignment is about FL networks, and the concept of this assignment is from machine learning to the federated learning. So right now we are saying the learning goals, like this is the learning goals of this assignment. We will implement a federated learning network using the Python package NetworkX. We will use this package to create the graph and their ages. And also we will analyze this FL network with their node degree and Laplacian matrix. And also after that, we will use some graph learning network in this federated learning network. And after that, we will use some kind of distance metrics like local averaging to know about this network. So these are like necessary libraries and packages which we have imported here. And after that, there is the first task, like building one federated learning network. And there has been the instructions as given like thoroughly. Like you have to make one, I guess two. Yeah, you have to make two graph using network X. One is geograph and one is statistical graph. And here some pre-processed data like the random seed and how will be the station data has been coded already. Like the latitude will be within 60 to 65 and the longitude will be 24 to 30. And these values has already been discussed here, like which value, what will be the values. And after that, the temperature mean and temperature standard deviation. And after that, like here is the like initialization of graph, but you have to implement some code, like how will you insert those nodes or like simulate the data set of those 100 temperature values here. So here you have to complete it, and then if you run this, you will see two graph will create. And after the sanity check, like if it's passed, then you can like understand that the two graphs has been created. And after creating the graph, we will create some edges of these networks. And since there were two graphs here, one is geograph and one is statistical graph or stat graph. So we will use some conditions here, like here is the behavior. Like if method is geo in this function, like constructing edges, then you have to use those coordinates using latitude and longitude. And if you use if the function parameter is stat, then you have to use the temperature mean and temperature standard deviation. So after that, you will construct edges, and there are some subtasks here. Like here is for geo, and here is for stat, and this is the like creating the neighbors node. Like the five, you have to take five closest node with an edge distance as weight. And after that, if you run this function, then the edges will be created. And after that, the federated learning, and after that, you can see the plots from here. Like you will see there are two similar plots, like the nodes will be similar, or I can say symmetric, but the edges will be different because one edge is based on geological properties and another edge is based on statistical properties. So that's why like the nodes will be same, but the edges will be different for the networks. And after then, the third task is to analyze the connectivity. Like you have to compute a Laplacian matrix here, and after that you have to compute the second smallest eigenvalue, like here, and the eigenvectors. And if you just uh, compute these values, then you will see a graph like here, analyzing graph, and you will see two graphs like how the uh, edges and the node are how much connected and what is the value of their connectivity. And after that, you can see a simple like algorithm of this network, like local averaging. Like it's a prediction error between the neighboring data, like neighboring data level temperatures of each nodes. So for this, you just have to like prediction error here, like here is a dictionary of prediction error, but you have to like create the differences, like calculate the differences, like here is already been instructed. Like you have to take the prediction temperature of the nodes, but if any node has no neighbors, you have to take the mean. But it is a rare case because like almost every node has neighbors because already in the upper field here, maybe there is just a moment. Maybe, yeah, here is like determine its five nearest neighbors. That means every node must have five neighbors. So if every node must have five neighbors, then that case is very rare. But it's just because so that you guys know that if anywhere in a project or any kind of experiment, if there is no neighbor, so what should you do? So just for that backup, but nothing more or nothing less. So and after that you will see, and after that just when you see the differences, you will see the local averaging differences of the nodes, and that's all for this assignment. I guess this one is a bit shorter than the previous one, so I hope, but it's a new thing like this federated learning network and network X thing. So I hope you guys will like it this assignment a lot. So this is from my end. So do you guys have any kind of question on these assignments or tasks or anything? Or like this assignment has already been shared yesterday. So have you guys faced any kind of problem in this assignment or anything? You guys can ask anything, so no worries. Let me just screen off my sharing. Okay, I'm just switching off my screen. Just a moment. What happened?
Hello, sir.
Yeah, sure. Does anyone have any question? Yeah, you can ask.
So I have a mental question. So the whole purpose here is to build the federated learning network from scratch without using any inbuilt libraries like Flower or TFF. Is that correct?
Yes, something like that. We are just using one package like Network X, but that's only for the graph. So we are not using any
Okay.
other libraries or any kind of packages.
Okay. So
Yeah.
will we be using them as well in future assignments?
Yeah, that maybe we will use it or maybe not, but it depends on the assignment requirements and other things. So let's see how it goes with the next
Okay.
assignments.
Okay.
And I will not be here for next assignments. Like Bo Zhang, the other teaching assistant, will take the next two assignments, and after that, Alexander, he will take the other two assignments, like assignment 5 and 6. So maybe that time you can see those like packages, or maybe not. So let's see.
Okay.
Okay.
Thank you.
Okay, so does anyone other have any kind of question?